Hello everyone. In this video, I'm going to tell you how I built this transmitter and receiver for my drone. So let's get started. So as you can see, this is the transmitter module. I am using one Nrf module with the antenna, two joysticks and two toggle switch. The OLED screen here shows all the details about whether the transmitter is connected with the receiver or not. It uses an Arduino Nano, and on the back this is the battery. We are using two 3.7 volt Li-ion battery. This is the transmitter. Now while making the transmitter, we must keep one thing in mind, that is always put a minimum 10 microfarad capacitor between the VCC and the GND pins of the Nrf module. The Nrf module works on 3.3 volt power supply and not 5 volt, so we must provide a separate 3.3 volt current for the Nrf module. The joystick, OLED display and the second joystick, both the joysticks and the OLED display work on 5 volt power supply, so we must connect the VCC pins of the OLED screen and the joysticks to 5 volt. You can see the circuit diagram, it is in my GitHub, link in the description. The transmitter. Now when I switch it on, you can see it's showing disconnected. That is because we have not yet turned on the receiver. So you can see the values over here. It's showing CH1, CH3, channel 1, channel 2, channel 3, channel 4, channel 5. I have not yet encoded the 6th channel because I will be only using the first 5 channels. So if I encode the 6th channel, it will display over here. So let's see if the values are working. You can see as I move the channel 3, it shows values. Channel 4, channel 1, so this was the transmitter. Now let's move on to the receiver. So this is the receiver module. I am using the Arduino Nano again and the small Nrf module without the antenna. If you want, you can use the Nrf module with the antenna as well. The connections and the coding will be the same. Over here the same thing. Apply a minimum 10 microfarad capacitor between the GND pin and the VCC pin of the Nrf module. And over here you can see the pins for a 6 channel. They are connected to D2, D3, D4, D5, D6 and D7 of our Arduino Nano. Now let's code it and we'll then set it up on our drone. the receiver, and now we are going to set this up on our drone. So this is the drone I'm going to use for setting up this receiver. This is a small drone that uses the KK 2.1.5 flight controller, you can see. So the motor and the ESC I have already attached them. So this is ESC1, this means this is motor 1, this will be motor 2, this is motor 3, and this one is motor 4. So the layout is motor 1 is clockwise, motor 2 is anti-clockwise, motor 3 is clockwise again, and motor 4 is anti-clockwise again. Now we'll set up our receiver over here. We will put it in the back so that there is no disturbance or any noise, and we can receive signals without lag, and the drone will fly better. One more thing to keep in mind for the receiver, that is the receiver works on a direct 5-volt supply. So we can't directly connect this to the battery, the lithium polymer battery for drones, that is the 11.3 volt. So what I have done is I have made this connection from the flight controller over here. As you can see, this is the extreme pins that are near the screen. Those are the signal pins. The middle one is 5 volt, and the extreme left one are the GND pins. So I have made this connection where we take one 5-volt pin from the flight controller and we connect it to our receiver. So the receiver will receive direct 5-volt supply from there, and it will work. So let's do the connections now. So these are the pins that I've done the connection with. So the green one over here is the signal, blue is the 5-volt, and GND is this purple one. So it will connect like this, because in our receiver the pin near the Arduino Nano is the signal pin, the middle one is 5-volt, and the extreme right one is the GND pin. So the connection will be like this. As you can see, this is the connection. Green is signal, blue is 5-volt, and the purple one is GND. Then the rest 4 wires. So now the rest 4 wires we can directly connect only the signal wires. We won't require any more GND or 5-volt wires. So I have only taken the signal wires from the flight controller, and we will connect them to the receiver. So the signal wires, this one is channel 3, sorry, this one is channel 2, this one is channel 3, this one is channel 4, and the last one, this is channel 5. So the connection for this one will be, this is the connection, the final connection. Then we will stick our receiver over here, and then we are going to set up the KK 2.1.5 flight controller. So now I have fixed the receiver at the back of our drone. This is how our drone looks right now. This is the battery connector, the XT60 connector. So now we will connect the battery, and we will program or set up the flight controller and check if our own build transmitter and receiver are working or not. So we have powered on our flight controller, and now we are going to set up the flight controller. So to begin the setup, we are going to open menu, and we are going to go at the bottom, at the very bottom, and perform a factory reset. There we go, factory reset, and we'll press enter. Yes. So now our flight controller has successfully performed a factory reset, which means that if there was any pre-existing setup or anything, it will all be reset. So now we have to set up this flight controller on our own. Go back, Now we have to select the type of drone we are building. So we are building a quadcopter X. This is quadcopter X. Now we will press enter. Yes. Now it shows all the motor direction. You can see that the arrows over the motor 1, 2, 3, 4, they are in different directions. So the it means that it is actually telling us which direction the motor should spin in. So motor 1, the arrow is inside, that means it will spin clockwise. Motor 2 will spin anti-clockwise, motor 3 again clockwise, and motor 4 anti-clockwise. So we will do next. There you can see CW. CW means clockwise, CCW meaning anti-clockwise. Okay, so we have 4 motors only, so the rest will be unused. We can use up to 8 motors back. So now you can see it's showing error because we have not yet performed the axle calibration and the receiver test. So let's again open menu. We'll go down. This ACC calibration. We'll press enter. Before doing the axle calibration, place the drone on a plain level surface land and then press continue. Okay, then we will do continue. Calibration successful. Now we will go up. This receiver test, we will click enter. So over here you can see all the values are showing 0, 0, 0. This means that our transmitter is not yet connected. So let's switch on our transmitter first. Link is showing connected. Now you can see that the values it's showing as I move the joysticks. As I move the joysticks, you can see the values are moving. You can see one more thing, that the auxiliary switch, as I switch it on, it shows auxiliary on. So I'm using the auxiliary switch to switch on and off the self leveling option. And to arm the drone, it's just like the ready-made fly sky transmitters. Pull your throttle down and extreme right. You can see it's showing arm as I do that, and again when I take it to the extreme left, it shows disarm. So this means our transmitter is working fine. Now we'll go back and we'll go down. We'll go to self level settings, enter. So as you can change this according to your preference. Next. So I'd like to keep them to this setting only, and we'll go to back and we'll go down. We'll go to mode settings. So you can see over here self level is showing aux, and if you don't want aux, you can change it to stick, always, none, and aux. So I prefer to keep it at aux. Back. Now the setup of our drone is complete except the ESC calibration. To do the ESC calibration, we will first disconnect the battery from the drone, and then simply we'll just connect it. Wait for the motor beep. That was the motor beep. That means the ESC calibration is successful. Now we will see if it's working or not. You can see self level, it's working. It's on. Now we will see if the drone arms or not. You can see it's showing armed. Now as we release the throttle slowly, the motors will start spinning. Now again disarm. So now I'll show you the motors spinning. I'll arm the drone first. Now as I release the throttle slowly, you can see the motors are spinning. So this means our transmitter and receiver are working fine. So the transmitter and receiver that we built on our own is working fine. So that was it for this video. I'll meet you again in a next video. Till then, take care. Bye bye.